Thanks for attending this presentation. In the next few minutes, I would like to present the results of our tests using CHT on APs. But before that, I would like to highlight the importance of guaranteed throughput by describing a typical case study on a train. Here it is. One AP fully integrated with CHT, our Wi-Fi optimization software. The AP's default physical layer has a great performance, but without an additional control layer, it will fail to satisfy the user's demand in a high-density scenario. The default firmware just implements the 802.11 standard, without additional intelligence. We will illustrate this issue with a case study. Imagine a train carriage with two APs. Each AP has two radios, one in 2.4 GHz and one in 5 GHz. This is a passenger that wishes to connect to the internet. Let us suppose that 24 passengers want to connect to the Wi-Fi network during the trip. There will be more passengers, but only 24 of them will use the internet. On the first day, we are lucky as the connected passengers have been uniformly distributed among the seats. Hopefully, the use of radio resources will be fairly distributed. On the next days, the distribution may change. There can be a family watching videos or a group of workmates doing video calls. The months go by and we see what happens. More days than we can imagine in principle, there are biased passengers distributions using the Wi-Fi network. And yes, there are some days when the passengers distribution is perfect from the radio resource management point of view. The key behavior here is based on the fact that the association logic of each user terminal, like smartphones, tablets, and laptops, is not defined by the standard. Each vendor has its own processes, but usually each terminal is connected to the strongest signal, to the first one found, or even forced to the 5 GHz channels in dual radios. This decision is selfishly carried out by each device, so the result is something like this. There are a lot of situations where some radios are saturated and other ones are empty. This is a catastrophic use of radio resources that makes the performance highly dependent on a stroke of luck. And yes, some days users will be surprisingly well distributed. In addition, there is another big issue regarding radio resource management. The electromagnetic spectrum is more and more saturated each day, and a self-channel selection approach will not work. The assignment of channels and bandwidths of the whole Wi-Fi network is a challenging optimization problem. APs with the default firmware will not take into account the opinion of its neighbor APs, resulting in suboptimal channel and bandwidth selection. This will have a deep impact on Wi-Fi performance, reliability, and throughput. As a summary, the bad use of radio resources leads to common situations like these ones. The performance of the Wi-Fi network can't be guaranteed as it is subject to a stroke of luck. The output delivered to the slowest user will be the guaranteed throughput per client. It is the data rate that the network operator can guarantee for every connected passenger. We can see that the network owner will receive complaints from unsatisfied users most of the days. And yes, there will be some days where the lucky distribution of users, channels, and bandwidths will result in a good Wi-Fi connection. To illustrate the quality of service, a guaranteed throughput of 2 megabits per second implies low resolution video for every passenger. With 5 megabits per second, you can guarantee HD video for every passenger, and with 10 megabits per second, you will guarantee 2K video. Take into account the exponential growth of video, gaming, and browsing demands, increased by IoT, and you will see a huge demand of guaranteed throughput in the next years. Here you can see some real complaints of unsatisfied passengers when using onboard Wi-Fi networks. This has a huge impact on the rail operator reputation and business. Let us see more reviews. There is a very good review about the onboard service on an airplane, and there are also 2 bad reviews about Wi-Fi onboard trains. This damages the company's reputation on a premium paid service. On the lower right corner, a good Wi-Fi review of an hotel as a marketing demand. And finally, let us see the result of a survey done in the UK regarding Wi-Fi onboard trains. Only 30% of the passengers were satisfied, and 56% rated it as poor. In addition, young passengers rated the internet connection as the most important thing for train companies to improve, above punctuality or even the bathroom cleaning. And this is a conversation on Twitter about the lack of a good Wi-Fi services, and the fact that it is perceived as a very technical challenge. We have simulated thousands of travels of our example train, computing the trends of the guaranteed throughput depending on the user distribution. Here is the histogram called 100 years of uncontrolled onboard Wi-Fi. It can be seen that the guaranteed throughput spreads from 14 megabit per second for the best die within a century to almost 0 megabit per second. And yes, the mean can be above 4 megabit per second, but the standard deviation shows that the guaranteed throughput varies a lot. Here we show also the 5th and the 95th percentiles. Here is where CHT enters into play. CHT stands for Cognitive Hotspot Technology. When you install our software in your APs, its potential is unleashed. They become aware of its surroundings and work as a team to optimize the radio resources in real time. Although CHT includes a lot of advanced modules, in the test report of today, there are 4 key algorithms that dramatically improves the performance in an uncontrolled, unpredictable Wi-Fi network. They are related to the automatic configuration of radio resources and of the load balancing. Remember the association in these example days? Please keep an eye on the screen to see what happens when clients connect to APs with CHT installed. There you go, as CHT assumes the responsibility of a fair distribution of users depending on the traffic load and on the utilization of the channels, the association and balancing of devices is much fairer. In addition, the channels, bandwidths, and powers are also configured in real time by the team of APs. As a result, the Wi-Fi network is able to guarantee an outstanding performance for every user, even the weakest ones. There are not underused resources. In this example, 15 megabit per second corresponds to 4K video streaming for every connected user. And finally, the histogram in this case is called 100 years with CHT. After thousands of simulated travels, it's very easy to see that the distribution is much narrower and with a higher average. With CHT, the guaranteed throughput will not go below 8 or 9 megabit per second most of the days. The standard deviation is much lower, so the network is much more predictable. Comparing with the non-CHT case, the improvement is different depending on the initial distribution and the specific scenario features. But most of the days, the improvements will be very notable. Okay, looking at the last row, it should be clear that some days the hardware without CHT will perform properly. But do you want to leave your performance to a stroke of good luck? As a summary, before showing the specific test results, in this slide we compare the guaranteed throughput distributions with and without CHT. The difference on the width of both distributions is a sign of the predictability of the onboard Wi-Fi performance. With CHT, it's very easy to guarantee a minimum on the throughput for every connected user, in this case about 8 megabit per second. Without CHT, this is not possible.